Alright, triangle similarity. So we're going to learn a couple theorems on how we can prove that if triangles are similar or not. Then we're going to use those theorems to find different measures of triangles. Okay, so here we go. First off, similarity means objects are similar, but they are not the exact same shape. They may be dilated, but the ratio must be the same on all corresponding angles, or on all corresponding sides, and the angles must be congruent. Okay, so here we go. Marker out. If two blank of one triangle are congruent to two blank of another angle, then the triangles are blank. Okay, this is your AA theorem. So this is if two angles are congruent to two angles of another triangle, those triangles are also, or not congruent, sorry. That is not the right word. I just read congruent and thought that. It is similar. Alright. Okay, so let's apply this theorem. So notice that the measurement of Q is equal to the measurement of angle C. They're both 78. And the angle R, right here at 47, is same as angle D, 47. So let's find the measures of angles S and E first. I know that the sum of the triangles have to be 180 degrees. So we're going to go ahead and add 47 plus 78. And we get 15 there, carry the 1. 12. So we get 125 when we added those together. So what I'm going to do is I'm going to take the 180 degrees inside the triangle, and I'm going to minus 125 from that to see what I get. So here we'll get our 5. We'll do old-fashioned math. 7 minus 2 is 5. That's 1. So there we have 55 degrees for my angle S and my angle E. Okay? So just 180 minus the sum of the other two. So here we go. So triangle QRS. So we just found the measurement of angle S was 55, which means the measurement of angle E is 55. Okay, let's add these together or find this information. So RS, what was the size of RS? RS is 16 right here from R to S. So we get 16 here. Let's see RQ. RQ is 15. And QS, so Q to S is 14. Okay, now let's find DE, DC, and CE. So DC is 6. DE is 6.4. And CE is 5.6. Okay, now hopefully what we'll find when we do this is the ratio should all be the same on all of these, on the corresponding sides. So if we look at RS, we're going to take 16 and put it over DE, which is 6.4. Those were corresponding sides. Then QS, which is 14, put it over CE, which is 5.6. And then RQ is 15, and we're going to put it over 6, which is its corresponding side. So all of these should be the same. So let's go ahead and grab our calculator. And we're going to do 16 divided by 6.4 is 2.5. Okay, 14 divided by 5.6 is 2.5. And 15 divided by 6 is 2.5. So we do indeed have similar triangles. So we just proved that the AA theorem, the angle-angle theorem, actually does work. Okay, let's look at a couple other theorems. If 3 blank of one triangle are proportional to the to the three corresponding blank of another triangle, then the triangles are blank. So this is if three sides are proportional to the other three corresponding sides, then the triangles are similar. Okay? So basically what that means, so notice that when we know all three side lengths on both triangles, we can determine similarity by comparing the ratios of the sides. It isn't necessary to know the angle measurements when using the side theorem. Alright, so let's see, so corresponding sides. So this is the smallest side on this triangle. So we're going to use a 10. And what's the smallest side on this triangle? It's the 12. So we're going to do 10 over 12 for our first ratio. Okay, the medium, or the second smallest on this triangle is 15. The second smallest measurement on this one is 18, so those two are corresponding. And then the largest on this one is 20, and the largest on this one is 24. So once again, let's go ahead and plug that into our calculator and see if those are all the same. So 10 divided by 12 is 0.83. 15 divided by 18 is 0.83. And 20 divided by 24 is 0.83. So there we just proved that those two triangles are similar because their sides were all had the same ratio to each other. They were all proportional. Alright. And we can skip that. That's what we just did. Okay, now we have the side theorem for triangle similarity. Okay, if two blank of one triangle are proportional to two corresponding blank of another triangle, their blank blank are congruent, then the triangles are blank. Alright, so if two sides of one triangle are proportional to two corresponding sides of another triangle, and their corresponding angles are congruent, then the triangles are similar. Alright, so let's take a look at what this means. So if we take a look at this one, they give us two sides and an angle between those two sides. So what we need to do is we need to prove that these two sides are proportional to these two sides and that the angles are congruent. Okay, so BA is size 15. It is corresponding to XZ. So there's 10. Let's see, and then BC is 36, and it's corresponding to the YZ, which is 24. So if we break these down, this is 1.5, and this is 1.5, so they are corresponding. And is angle B, the angle between these two sides, the same as angle Z, which is the angle between their corresponding sides? Well, they're both 90-degree angles. So since they're both 90-degree angles, we know that they're congruent. So we have two proportional sides, and the angle between it is the same. Therefore, we know that these triangles are similar based on the side angle side theorem. Okay, so let's look at these. Determine if the triangles are similar. If yes, state which theorem you can use to prove it, and write a similarity statement. Okay, so this triangle right here, looks like we have two angles that are congruent. Here we have two angles that are congruent. And we know that if this angle is congruent to that one, and that one's congruent to that one, that they're going to have this angle also congruent. So this would be similar from the angle. They have two angles that are the same. So we can say that triangle ABC is similar to triangle. Now we wrote this one as ABC. We have to write this one in the same pattern. So we started with A that had the double angle, or the double lines in the angle. So if you look over here, Y has the double lines in the angle. So we're going to start with Y. Next I said B. B had the one line. So over here, which angle has the one line? It's the Z, and then just our last one. So triangle ABC is similar to triangle XYZ. Okay? Let's try this one right here. Alright, so we have 81 degrees right here and 81 degrees right here. And this one is 40 and this one's 60. So those aren't congruent. But let's see about this one. So if I had an 81 and a 60, 180 minus 81 and 60 would be, oh, my mind just drew blank, 39. And if I had 180 minus this, that would give me a 51. So do I have any two angles that are the same? I have 81 that's the same, but the 40 and 60 is not the same, 39 and 51 is not the same. So this one is not similar. We can't prove that one to be similar. Okay, here, determine if the triangles are similar again. Okay, we have a side and an angle and a side is what's given to us. So we're going to check to see if this theorem would work. So we got to see 3 over 6 equals a proportion of 1/2. Okay, 4 and 8 are corresponding sides, so 4 over 8 equals 1/2. Okay, so we have corresponding sides. Let's go ahead and see if the angles are congruent that are between those two. This angle and this angle are congruent. Therefore, we know that they're similar. So we are going to say, these don't have sides on them. So we're going to call this A, B, C, and this D, E, F. So we're going to say triangle A, B, C is similar to triangle D, E, F, and then we need to say it by what theorem? By side, angle, side. So if we go back to this one, we found these to be similar by AA, because that's how we found it. Okay, and then this last one. It looks like they gave us 3 sides, so we need to see if all 3 of those sides are proportional to its corresponding sides. So let's take the smallest side, which is 16. The smallest side here is 20, so we're going to take 16 over 20, figure out what that proportion is. Then we're going to take 18 and 22, figure out what that proportion is, and then 20 over 25 to figure out what that proportion is. Okay, so if we do 16 divided by 20, we get 0.8. If we do 18 divided by 20, we get by 22, sorry. We get 0.81, and we get 20 divided by 25, and we get 0.8. Alright. So these ones are really, really close. I think they meant to try to make this so that it would be. But we're going to go ahead and say, since they're not exactly proportional, we're going to say that it's not similar. But if they were all proportional, we would say similar through the SSS theorem, if all 3 of these numbers right here were the same. And I think they probably were trying to get it so that it was. So if I rounded this just to 0.8, then we could probably say that they are proportional, which means they would be similar through SSS. Okay? Alright, we're going to go ahead and end the video there. And if you have any questions, feel free to ask me, email me, and I'll get back to you.